Let's work on a few conditional probability questions. Let's say that we have a bag with four different marbles, four blue marbles, one of which is striped, three are solid, three red marbles that are all solid, and then five white marbles, four striped, one solid. So we're going to be asking probability questions. It's probably a good idea to add all these up. Four blue plus three red puts us at 7 total, plus 5 puts us at 12 total marbles. So we have 12 marbles total. All right, let's answer this first question. What is the probability of drawing a striped marble if you know that it's white? So this is a conditional statement because you know something and then you're asking a probability question, right? The probability of a striped marble given that it's white. In fact, let's remind ourselves of the conditional probability equation. The probability of A given B is the probability of their intersection. So both of them happening, and then divided by the probability of B, right? You know that B has happened, so you restrict yourself to the size of B, and then you compare the size of A inside of that. All right, so here, the probability of pulling a striped marble, given that we know that it's white, would be the probability of striped and white, right, their intersection, divided by the probability of it being a white marble. Now, if we look at the breakdown of the marbles in the bag, how many striped and white marbles there are? 4. So the probability of pulling oops, that doesn't look good. The probability of pulling the 4 striped white marbles is 4/12. And then what is the probability of drawing a white marble? There's 5 total white marbles. So there's 5/12 probability of pulling that white marble. With a little bit of algebra, your 12s cancel, you're left with 4/5 or 80%. Right, and you didn't actually have to go through this equation. You could have just said, what's the probability of striped given white? Well, if you restrict yourself to these 5 white marbles, what's the probability that it's a striped marble? There's 4 of those. Right, either way, you get 80%. Right, thinking about it intuitively versus actually using the equation. Okay, let's clear off the board and work on number 2. The probability that we draw a blue marble after we have already drawn a white marble. So in this first example, we were only performing one probability experiment, one event, and we were counting the intersection of 2 different qualities of that event. In this second part, we're viewing 2 different events as a single large event. We're drawing a marble once, and then we're drawing another marble. So we need 2 things to happen. So what is the probability that we draw blue after we know that that first draw was a white marble? So probability of blue on the second draw, given the fact that the first was white. Okay, so if we view this as a conditional probability and we're pulling twice, then the intersection would be that we got blue on the second draw and white on the first. Oops, I don't know why I wrote first out, but not second. White on first. And we compare that to the size of the given statement. So we know that we have a white marble on the first draw. Okay, let me zoom in, get some extra space here. Okay, let's think about this top probability. The probability that we draw blue on the second and white on the first. So if we draw white on the first, there's 5 white marbles out of the 12. And then, right, so we have an intersection here. We multiply the probabilities. So white marble on the first draw, this needs to be the probability of blue on the second. So on the second draw, you no longer have 12 marbles, you have 11. And how many of those 11 are blue? We started out with 4 blue marbles, and we drew a white one, so we still have 4 blue marbles. Right, so that right there, the product of those two probabilities give me the probability of blue on second and white on first. I divide by probability of white on first. So we've actually already seen that. That's 4, oops, not 4/11. That's the 5 blue marbles out of the 12 marbles on the first draw. So this is kind of like a trivial conditional statement. The 5/12s cancel, and you're left with 4/11, which gives you 0.36 or 36%.